Hello to everybody, and thank you very much for watching this short lecture video. In this video, I'm going to go through electron configuration. I will try first to order orbital and show you why, for example, s orbital, it will be the first orbital that we will put electron in it. And we're going to start with this one. Let's just start ordering the orbitals based on their energies. When it comes to orbital that they have the same n, so n it will be the same for them. And for example, we have 2s versus 2p. We're going to say the one that has lower s will have lower energy. So I'm going to say energy of the 2s orbital is less than energy of the 2p orbital. What does it mean? It means the 2s orbital is sitting lower level in energy than the p orbital. So you will have the 2s here, and then you will have the 2p orbital. You want to put the electron and inside any of this orbital, you're going to start with the 2s orbital because it has lower level of energy. So if we are sharing same n, in that case, we're going to go after L, and the one with the smaller L, it will have lower energy. So how about n equal 3? If n equals 3, the possible answer for L is going to be 0. That's the s orbital. Next one is going to be 1. We call it the p orbital. And the third one, it will be 2. We call it d orbital. So I got 3 orbitals. One is going to be 3s, and then 3p. Now we have 3d. I want to order these orbitals based on their energies. And this is going to be the order for them. We're going to say the 3d orbital, it has higher energy than the 3p orbital, and then 3s orbital, it will have the lowest energy. Okay, so again, what's the meaning of it? Meaning of it, the 3s orbital, it will be the first orbital to put electron. Then you will have the p orbital, 3 of them. And after that one, you will have the d orbital, and you have 5 of them. So start with the 3s, 3p, and then we will have the 3d. Okay, but the 3d, because it's going to be too close to the 4s orbital, that's going to have some exception, and we need actually to review it before we just simply put the electron inside d orbital. Okay, let me show you why when electrons when n is the same, in that case we say we go with L. Okay, let's show electron configuration, the radial distribution graph for 3s, 3p, and 3d. Okay, and the way we get the radial distribution for them, let's, for example, go with the 3d. 3d, n is equal 3, L is equal to 2. Okay, so we say number of nodes is going to be n minus 1. Okay, so you go 3 minus 1, we have 2 nodes. And those 2 nodes, we're going to distribute them between angular node and radial node. And what's the angular node? Angular node is equal to L. In this case, L is equal to 2. So we have 2 angular nodes. How about the radial? Radial node, we're going to have 0. Okay, no radial node at all. Okay, and angular node, you show it by a plane. Well, radial node, we'll show it by a circle. Okay, let's show the d orbital. Okay, this is a d orbital. Okay, I'm going to show the angular node. The first angular node, let's put it here. That one is the first angular node. And the second angular node, I'm going to put it in this direction. Now, let's give it a sign. It doesn't matter what's the sign. Say this one is negative. Now I go positive here, negative, and that one, it will be positive. Okay, radially move out of the nucleus. This is going to be center of the orbital. So I'm going to say this is going to be the radial distribution graph for it. We will have probability of finding electron, or chance of finding electron, that we show it by psi 2. Psi 2 is the probability of finding electron versus distance from the nucleus. Okay, if I move from the nucleus outside of, to outside, and I'm gonna have such a graph. Okay, and I will get this one, and forgive me. Okay, There is no like a radial node, and as you see, the graph did not, this graph did not hit the horizontal line. And so what should I call those 2 points? Those 2 points, that's going to be the starting point, okay, starting point of the orbital, and that's going to be the end of the orbital. So we don't have angular node. Okay, now this is going to be the radial distribution graph for the 3D orbital. If you show the radial distribution graph for P and S orbital, you will get this. Okay, so I'm going to put them top of each other. So we have probability of finding electron versus distance from nucleus. This is going to be the 3D orbital. Okay, the 3D orbital does not have does not have any like in radial nodes, so we get this one. Okay, now how about the 3p orbital? 3p orbital, it will be like this. This is the 3p orbital. Let me show you the radial node for the angular node. We have one angular node and we have one radial node. Here you go. This is radial node. I go plus, minus, this one plus, minus. Okay, radially move out of the nucleus. So we have 2 bumps. Okay, the first bump is going to be, let's say, okay, maybe I think I need to adjust this one a bit. Okay, so I'm going to say this is the d orbital. Okay, the 3p orbital, it will be like this. You get 1 bump here, the second bump, it will be there. Okay, so this is going to be the 3D orbital, and that one is the 3p orbital. Okay, and the max point for the 3p orbital, it comes after the 3D orbital. Okay, and what do I have here? I have penetration. Okay, so I have penetration here. The penetration, as you see, we don't see it for the 3D orbital. Penetration is making the 3p orbital closer to the nucleus than the 3D orbital. Listen carefully. The penetration orbital, penetration is making the 3p orbital closer to the nucleus than the 3D orbital. Now, if you show the 3s orbital, it will be like this. So we have a nucleus, 1, I go 2, I have positive, say this one goes positive, negative, positive. Okay, and if I move radially outside of the nucleus, I get 3 bumps. So the first bump for it is going to be somewhere here. And again, we got penetration for 4s orbit. There's a 3s orbital, so this is going to be a 3s orbital. That one is the 3p orbital, and the max point for 3s orbital, it comes after all of them. Okay, after the 3d and 3p orbital. And so based on max point, 3s should be the one with the highest energy because it's way far from the nucleus. But the 3s orbital, it has two penetrations. Okay, 2 bumps. And if you look to it, one of the bumps for the 3s orbital is really close to the nucleus, and that penetration will make the 3s orbital is really, really stable. So when it comes to orbital that they have same n, so if n is the same, then look for L. Okay, look for L. And I'm going to say the 3D orbital, because it has L equal to 2, it will have higher energy than the 3p orbital, where L is equal to 1. And the 3s orbital, it has L equal to 0. So that's going to be the one with the lowest energy. Okay, now let's talk about 4s and 4s orbital and 3d orbital. Okay, if n hit 4 or higher, in that case, a gap between 4s orbital and the 3d orbitals are going to be really close to each other. Okay, and anything that stabilizes the 4s orbital, it might put it lower energy than the 3d orbitals. Okay, let's talk about those. So this is the radial distribution graph for the 3d orbital. Again, this is the 3d orbital. 3D orbital. How about the 4s? 4s is going to have 3 nodes. Okay, so it will hit the horizontal line 3 times. Okay, this is 1 node, 2 nodes, 3 nodes, and that's going to be the 4th one. This is going to be the 4s orbital. So if I look to the max point, okay, those are nodes, that's n. Okay, the first node, this is the first node, that's the second radial node, and this is the third radial nodes. Okay, remember, number of nodes equal to n minus 1. N minus 1, so you go 4 minus 1. We have 3 nodes, and if L is equal to 0, angular node is going to be equal to 0. And so we will have 3 radial nodes, and here you go. After those three of them, there will be radial nodes. Okay, penetration is making the 4s orbital lower in energy. Okay, this is the 3d orbital, and this is the 4s. Okay, where is 4s? 4s is a bit higher than the 3d normally. Okay, now penetration and penetration, we do have it for 4s, but not for the 3d. So what will happen? For 3d stay as it is, but 4s, it will get stable a bit because of the penetration. Now, penetration made the 4s more stable, and just enough more, like enough stable to be lower in energy than the 3d orbital. So if n is 4 or higher, in that case we say the 3d orbital will have higher energy than the 4s orbital. So remember this, energy of the 3d orbital higher than 4s. What does it mean? You put the electron inside 4s orbital, then you go after the 3d orbital. And thank you very much, and I will see you very soon.